So a great way to start this question is to ignore the fact that people are going more than once and just figure out how many visits there are. You have a calculator for this section, so use a calculator for appropriate things like adding up a bunch of numbers. What's your most valuable asset on tests like this? Your wow, you suckered me into saying that. No, it's not. Time. Time is your most valuable asset. On the AP test, for example, they give you more time on the calculator section per question only because kids tend to waste time like messing around with their calculator, like over-verifying. Use it for only the things you absolutely need to use it for. Don't use it as too much of a crutch. So if you wanted to figure out how many visits there were, you need to read that graph properly. So if you actually go in and look at this right here, you need to make sure you read this. So that one's going to be, what, 22? That one's 26. What's that one, 18? This one is what? That's 8, not what? Or 9. Sometimes you look at 10, you go 1 down, you're at 9. When I did this first time, I was like, oh, it's 9. It's definitely not 9. These are all even numbers. That's going to be what? 20. What's this going to be? And this one's going to be 22. So if you add all these numbers together, you get the total number of visits, not accounting for repeat visits. Not accounting for repeat visits. So if you add all these up, I just don't do things that quickly. You get 140. So if you add all these together, you get 140 visits. So one thing you'll notice too is that do they list, is 140 there? No, so you definitely don't have a solution. First tip for you, just because the answer is there, does that mean it's necessarily correct? No, they spend a lot of time coming up with false answers to this, a lot of time. They come up with basically they test out all the different ways people do these wrong, and then they list those like 5 most common answers. That's how they generate these things. They are trying to trip you up. They're trying to trip you up. So they tell you, though, that the people that went to lunch also went 2 other times. How many people went to the lab during lunch? There's 8 of them, right? So how many times are those people getting counted in that 140 visits? Well, they're getting counted 24 times. We've already counted them how many times in here? We've already counted them once, right? We've already counted their visits once for the lunch block, right? So what do we need to subtract? We need to subtract 16. Because they also went 2 other times. We've already counted them once. So we subtract 140 minus 16, and what do we end up with? 124. And that is answer D. Does that kind of vaguely make sense? It's the number of visits minus the overcounting. You do this a whole lot in big number questions. The hard thing is finding those small things you need to take away. 9, well, almost. 4. I got it. So 4. Now here's the thing. Each triangle that we're making is an area of 4. Each area that this triangle, the smaller one is 4, the bigger one is 12. So how many of the small ones fit into the big one? You went to the answer. I see what you're saying. It went in 9 times. Now, what's interesting about this is we did the division. Does it ask us how to divide it up? Does it ask us actually how to divide the triangle up? Like just because we said this, like for example, like when you fill this place with basketballs, right? If you divided the volume of this space by the volume of each basketball, is that going to be accurate? No, because when you put basketballs like into a space, does it fill up all the space? No. So this doesn't guarantee it, but is it good enough? There are lots of holes in logic like this. Some of these questions, if you think about them too much, they have major problems. It's kind of, and also, do they want you to overanalyze them? No, don't get stuck down that rabbit hole. There's people, you see jokes like that. It's like there's a boat in the water's traveling at a certain speed, and the wind is moving it, right? Some people are like, well, if it's closer to the shore, it's slower because there's, I don't know if you know that current on the water is slower over near the side. Don't overthink these. That's actually true, and it's kind of, anyway. To construct a 4-digit number, you need 1, 2, 3, 4 digits, right? What does it tell you about the 100th digit? It just tells you it's 1. What is it? It says it's 8. So you know that this is 8. You know that the number is divisible by 5. So what does it have to end in? This is 0 or 5. Does it say anything about the other digits? So they can be anything. How many things could go right there? How many different numbers? 0 could go there too, right? It could be 0, 1, 2, all the way up to. So 0, how many numbers is that total? 10 of them. How many numbers could go there? How many numbers right there? This is where people will get it wrong. This is where I think it's guaranteed to get wrong. So you did 10 right here. Is it 10 right here? You can't have a 0 or it's considered to be a 3-digit number. So this is 1 through 9. So how many is this? So that's 9 choices, 1 choice, 10 possible, and 2 possible. So how many numbers do you have? 9 times 1 times 10 times 2, which is 180. Does that vaguely kind of make sense? Vaguely, kind of, maybe, sort of? It's a little bit out there, and there's a reason. Does that kind of make sense? Make sure you use all the information and literally draw pictures. Draw pictures. It helps. Draw pictures. Method you need to use for something like this? What should you do? Yeah, literally, the best way by far on this is to plug in numbers. I tried in my head to find out some algebraic way to manipulate this, to say like definitively like which ones are true. The problem is there's no good way to do that. You have to logic it out, so you might as well, because look what it says, could be true. Does it say always true? That would make it way, way harder. Way harder, so it could be true. So all you have to do is come up with examples. So x is greater than y, just pick a number where x is greater than y. And my tip for this, pick extremes, and maybe not start with 1. Of 1, 2, and 3, which one would you like to start with? Which one do you think is the easiest? The third one, right? Two numbers that are equal. Well, x and y are going to be the same no matter what, correct? This is going to be the same as this, but this is subtracting, right? If you subtract something from something and it's positive, so let's say 5 and 5 is x and 5 is y, what's going to happen? One will go smaller and one will go. So which one could be true? Could 3 be true? Can this be true? 5 plus 1/5, is that greater than 5 minus 1/5? It is true, right? So just pick it. Oh, it works. Okay, let's do, which one do you want to do? 1 or 2 next? So, hey, pause. Can we eliminate any of the answers? Yeah, that automatically eliminate. And what do you know about eliminating answers? If you can eliminate any answers, what should you do? Only guess if you can eliminate an answer. And my other tip for you is make sure your guess is random. Humans suck at guessing. They don't, if you get a bunch of A's, what do people tend to do? Oh, it can't be A on the next one, it must be B or C. Totally not true. Totally not true. Humans are terrible at guessing. We're not good at randomizing. So if you want to guess, literally, I'm not even kidding, like if you have a, maybe not a coin, but find a way, literally like get a little piece of paper and then like toss it and like whatever one's closest to you, pick it. I'm not kidding, it'll help you. Better guessing. I also think that the PSAT is going to eliminate the penalty for guessing and just recenter the scores. They did that on AP exams. There's no penalty for guessing on AP because, here's the thing, kids who are better at guessing do better on this. Is that what the test should be about? Theoretically not. It shouldn't have anything to do with your ability to guess. Yes? What do you want to talk about next? 1 or 2? 1. Go for extremes. So when I say extremes, pick numbers that are enormous, right? Pick numbers that are huge. So how about like x is 1 billion and y is 1? Is it true? Is this statement true when x is 1 billion and y is 1? Yeah, it's true. So could the first one be true? Yes, it can. So you go down here and which one can you eliminate? Oh wait, 1. So it has to be 1 and 3, right? It has to be 1 and 3 in there. So which one can you eliminate? You can eliminate D because 1 isn't there. So now we're even better off. So now we have to do this one. Now, and this is the trickier one. You have to come up with a good example that makes this work. If you invert it, let's see what happens. Is it true if x, so you might say like 1 in 1 billion, right, for y? If x is 1 and y is 1 billion, is it true? No, but how many other examples can you test? Potentially an infinite number, so it's hard. Here is what you need to think about. When you're dividing something into 1, could these be fractions? Could these numbers, x and y, be decimals? Is that possible? So how about we make x equal to, I don't know, 0.00001 and y equal to 1. Is that true? Is 0.0001 less than 1? That is true. So let's look at this statement, for example. On this side right here, on the left side right here, that's going to be 0.00001 plus 1 over 0.00001. What's 1 divided by 1? Tens, hundreds, thousands, 10,000, 1/100,000. What is this? Yeah, that's 10,000 right there. Oh, we plugged in, what did we plug in for y? 1, right? We plugged in 1. What's 1 minus 1 over 1? What's bigger, 1,000 or 1? Or 0, sorry. 10,000. 10,000 is bigger. So can 2 be true? Yes, we did it out, and this side came out to be 10,000, and this side came out to be what? 0. Is 10,000 bigger than 0? Yes. So the only lesson here, everybody, the only lesson here, and this is probably one of the hardest ones on here, does it say what x and, do x and y have to be integers? No. If you get stuck and think they are just supposed to be integers, you will not be able to get this right. Because you'll think of like 1 in a billion. Well, if you plug in anything less than 1 for x and then 1 for y, you'll come up with an answer that does make it work. So just remember, decimals are also potential answers. Yes?
Should you use negatives?
You could. There might be other examples, exactly. Does it say anything about positivity here? No, they could be negative. Could you? Absolutely. Also, side note, just because I come up with one method doesn't mean there's other potentially better methods. Absolutely. Same slope. They're perpendicular if they have what? Opposite reciprocal. So if the slope is a over b, for example, what's the opposite reciprocal of a over b? Negative b over a. The better way, honestly, to remember this is two lines are perpendicular if their slopes multiply together to get what? -1. Just remember -1. They have to multiply together to get -1. So they're asking which of these points is on the line that passes through the origin and is perpendicular to this line. So if you want to know if a point is on a line, you better have the equation for the line, right? Which equation? There's lots of different ways to write the equation of a line. I have an opinion, and the people that have had me don't say this. What's the best one by far? I'll give you a hint. It is not slope-intercept. Point slope, by far. Y minus y1 is equal to m times x minus x1. This is awesome because all you need is any point and a slope. Do they give you a point? The origin, right? They tell you it's the origin. So we have a point, which is 0, 0. We could plug that in. Y minus 0 equals m times x minus 0, right? What's the only thing left that we need? The slope. Well, we know the slope here is 3/4. So what's the perpendicular? Upside down t means perpendicular. What's the perpendicular slope? -4 over 3. So what's the equation of this line going to be? Y equals -4 over 3 x. That's not what it's asking. It's asking which of these points is on that line. So then you can look at this and say, well, how can we eliminate answers? You could plug the numbers in and start computing, right? There's other ways to think about it, though. If x is positive, y is going to be? Look, negative, right? And if x is negative, y is going to be? So you know that x and y have to have opposite signs. Oh, look, you can get rid of that one. You can get rid of c. You can get rid of e. So it has to be either b or d. Then you plug them in. Which one is it? Is it b or d? Which one is it? It's b. They want to sucker you into doing d because they've inverted it. It's not correct. So it's going to be b. Here's the deal. Time is your most valuable asset. If you look at something, you're like, oh gosh, oh gosh, oh gosh, just skip it and come back to it. This might be one that I personally would skip and do last. It's pretty easy to identify sometimes when you should skip them. This is one you should skip and do last. When I did this one, I wasted a lot of time finding the wrong thing. Anybody want to guess what I tried to find of this shape? I tried to find the volume. So I looked at it like, man, I got to find the volume of this thing. And I got an answer, and I was like, man, it doesn't work, trying to find my mistake. My only mistake was it is asking for what? Surface area. You're told this on any topic. It doesn't matter. Make sure you understand what it's asking for and do it in pieces. What's nice about this is you really only need to find the area of two shapes. You have the shape of one of these sides. It's a square, right? So what's the area of that square going to be? It tells you that the length of each edge is 5. So what's the area of that square that I just made? This right here. Yeah, this is going to be 5 by 5, which is 25. How many of these are there? There's the front, the back, the top, and the bottom. There's 4 of them, so that's 100 so far, but is that everything? No, because we have a pyramid, right? What's nice, though, I'm pointing at those 4 sides. It's kind of hard to see. What's nice about the pyramid is you see this side of that pyramid right there? You see this side right there? What's the relationship between those two sides? They're the same. How many of those triangles are there? There's 8 of them, right? But what do we know about each of those triangles? We know each of those triangles is what type of triangle? Side lengths of 5. If you want to find the area of a triangle, what's the area of a triangle equal to? 1/2 base times height. Well, we have a base. What do we not have? You don't have this height, but you need to find it. Can you tell me what the distance is from here to here? 2.5. I like fractions. 2.5. You need to find the height. What theorem do you need to use? 5 over 2 squared plus h squared is equal to what? 25. 5 squared, correct. So you have h squared is equal to 25 minus 25 over, close, 4. So h squared is equal to 100 over 4 minus 25. To add or subtract fractions, what do you need? You have any idea how many times I see advanced math students make really crippling mistakes that they shouldn't? I see this all the time, like, oh, I'm just not going to have a common denominator. Or how many times have I seen this? Just take a guess. Oh, that's good. I kind of die on the inside a little bit when I see that. Please don't do that. Please don't. So can we keep on going here? Or for those of you that have taken more advanced math, have you seen this one? Sin x over n is equal to 6, right? Yeah, you can't do that either. I guess you need more trig to understand that. So what's h squared going to equal? How many fourths are there? Nice, but it's h squared, so it's going to be the square root of this thing. So that's equal to the square root of 75 over the square root of 4, which is over 2, right? It's nice to simplify this, though. This is the square root of 25 times the square root of 3. What's the square root of 25? Did we just do this in class? Maybe today? Was that it, Nick? Today, right? Yeah. So what is that? That's our height. We're not done yet, though. But now that we have the height of the triangle, what can we find? The area of the triangle. Area is going to be 1/2 the base, which is 5, times 5 root 3 over 2. Can you clean this up a little bit? Kinda. What does it become? You know, it's going to be 25 root 3 over what? Well, 2 and 2 is what? 4. How many of these are there? Let's go back to the picture. How many of those triangles do you see? There's 8 of them, so what do you have to do? Yeah, it's going to be 8 times 25 root 3 over 4. 2 times 25 root 3. So what is that? 50 root 3. So we went up here. We found the area of the top. What was it? It was 25 root 3 over 4, like that. So that's 50 root 3. So what's the total surface area? Is that one of the answers? This one right here sunk the most time out of, like pulled the most time out of me on this one. That's just the work. That's the quickest way I know how to do it. The other thing, the only thing really that could make this faster, I wasted a lot of time because I tried to find the what. Yeah, don't. It's worse, okay? Don't do the volume. And it's also wrong, so don't waste your time. The only other way you could do this is if you memorize the formula for the area of an equilateral triangle. I misread it. I said, like, what's the volume? And then when you do it, I was like, why aren't there any root 2's in it? I was like, oh, surface area. He makes $250 plus 1% of what he sells. And what does he sell? 15,000 plus 22,500 plus. So what is, if you do this out, this is what you would use your, you could, it's not impossible to do this by hand. I mean, you do 250 plus 150 plus 225 plus 250. But even if you could do that out by hand, should you? No. Just make sure you type it into your calculator correctly. I typed it in and I got 845. I'm like, it's actually 875. What? No, it says $250 plus 1% of the selling price of each of the cars. It's not, the 250 is not for each of the cars. It's $250 basically. It's like when you work for tips as a waitress, you get a certain hourly fee plus your tips. You don't get like a per table amount. You're right, it's not super clear, but that's what it is. It's $250 plus 1% of the total of what he sells. 7. There's 7 pieces. No, they gave you the picture so you can actually pay attention to it. My guess is they did this question without a visual representation, and more kids got it wrong than they liked, so they added a picture in to help people with it. Does everybody see? Take a look at the fan. How many pieces do you see? 1, 2, 3, 4, 5, 6. That's what they mean when they say 7 pieces of bamboo. But then how many divisions are there? 1, 2, 3, 4, 5, 6. What is the greatest possible value a fraction can be? So let's not even look at this. If I gave you a fraction, how can you make a fraction bigger? There's 2 ways just by modifying a and b. If you want to make this bigger, what do? Yeah. Yeah, so yeah, A needs to be as big as possible, and B needs to be as small as possible. If these two things are numbers between 500 and 1,000, what's the smallest the difference can be? What's the smallest? 1. You could pick two numbers that are 1 apart, correct? Correct, and you're not doing it because these are two different integers, right? Look, integers, you see that? So the smallest the difference could be is 1. Okay? If you do that, you might think, oh, maybe negative, but the thing is you want the whole thing to be bigger, so keep it positive. How many pairs of numbers have a difference of 1 in there, though? 500, 501, 600. Okay, so, but you want this to be 1, agreed? But then you also want the top to be what? Big. But careful, they have to be two different numbers, right? So what are the two biggest numbers you could choose? 1,999, right? So if you did that, you would get 1,000 plus 999 all over what? Exactly, and what do you end up with? 1,999 over 1. So the answer to this is actually 1,999. A fraction gets bigger when the numerator gets bigger, or the denominator gets smaller, or both. So you aim to maximize those two things. Again, this one's hard because is there an algebraic solution method? So I just drew it and then I wanted to see what would happen. Because I did not honestly see just, oh, I know how to do this one. But what is A? What does it tell you the point A is? Negative 2n. What is point B? Negative 1, 2n. What's C? 4k. And what is D? 3, 1. It also tells you that n is between 4 and 2. It asks for what is one possible value for k. It asks you for one possible value of k. Now here's the thing. This is the thing about this question. I'll get right to it. That tripped me up for the longest. Could this parallelogram, could you move it? Could you tilt it? Yeah. The only reason I made it level with the screen was because I have a grid like that. If I cut that parallelogram out and just tilted it, is that a valid thing for me to do? Absolutely. The thing you have to check, though, is it's giving you all of these points right here. These are the important pieces of information. So, for example, I looked at this, and the first time I realized it needed to be rotated was the following. Look, it tells you, let's say this was a horizontal line. Okay? Horizontal line, what's an equation for a horizontal line? Is it x equals or y equals? It's y equals. So that horizontal line would have to be y equals what? 1. Look right here. What is D? What's the y value? 1. But if these are on the same horizontal line, what would n have to be? Can it be? No, n has to be what? Between 2 and 4. So you know it can't be, n needs to be greater, right? So this point right here better be lower down. So then I thought to myself, it's got to rotate down a little bit, right? Imagine there's a nail right here. And imagine we're swinging the parallelogram on that nail. This point D has to go down. But if point D has to go down, what happens to all the other points? They go down as well. Are you with me so far? What? Are you with me so far? Okay, so I tried to do this. I tried to logic it out. But here's the problem. If you start rotating the shape, does it get really complicated? The math gets complicated, and you should realize when you're going places that you don't know how to do. I'll tell you one thing. This is just a basic truth. Rotating shapes, guys in the back, if you talk quieter. When you rotate shapes, math gets really hard. This is something they're looking at in discrete, like how you move shapes around. It's not easy. So then I reevaluated this, and then I kind of tried something else. I started noticing something. Look at the x values here between A and B. What's the difference between the x values between A and B? How far over to the right do you go? So from here to here, what is it? 1. If I drew this right here, what's this distance? 1. So here's the thing. This is 1. That's 1. You know this is a parallelogram, so this side is congruent to that side, correct? So what can you say about this triangle and this triangle? They're not actually better than similar. They are what? They're congruent triangles. Now here's the thing. If I have two congruent triangles and I move them, does that change anything about their congruency? No. So here's the thing. You know that this distance right here and this distance right here have to be the same because those two lines have to be parallel because what are they? It's a parallelogram, right? Is everybody with me so far? So if I oriented it like this, I'm kind of doing a hand-waving method of this, you go from 2n to n. So what's the height from here to here? 2n minus what? N. Are you with me so far? What's the distance from here to here? So then I started saying, okay, so you see that right triangle right there? It's a right triangle, correct? What's the base of that right triangle? What's the height of that triangle? Which is what? Equals, this side has to be equal to that side, correct? What's the distance here? What's the height here? What can you eliminate from both sides? This goes away. So n squared is equal. So I got to this and I was like, huh, that's weird. What can I do with this? What does it tell you about n in the question? 2 and 4, right? So n, you know n is between 4 and 2. What's the golden rule of algebra? Anyone remember? Scale, what you do to one side. Am I allowed to square both sides? If they're both positive? Yeah, if a equals b and they're both positive, can you square them? You can't if they're not. So if you square all of these, you get 4 is less than or equal to, is less than or equal to. 16 is like, oh, but what do I know? What do I know right here? What does n squared equal? So 4 less than k minus 1 squared less than 16. I know, this is pretty nasty, huh? How do you get rid of a square? I can almost write a 4. What do you add to everything? That's nasty, isn't it? I can pretty much, kids, here's the thing. I can pretty much guarantee there's a simpler way to do this one. I'm not going to get into it right now. I'll check in with somebody. If you found a simpler way, that's totally fine. This is the correct answer. This is a nasty question because when I read this, I thought the answer would be like one number. I thought you'd do some algebra and the answer would be like 4. What is one possible value, right? So I guess they will accept any number between 3 and 5. So I think there is a way to logic it out, which is fine. I'm not going to get into it right now because I want to cover some more and I'll come back to this. But they would accept any number between 3 and 5. Exactly. They would accept anything. But this is the whole set right there. That is the hardest one. It says hard, but I'll tell you this one's a lot easier than the one we just did. That's what I'm trying to tell you. So look, it tells you f, the function f is something. It tells you the function g is something. And then it plugs in 5 into f and 5 into g. So does everybody see f right there? What is f of 5 going to be? Well, yes, but it's going to be 5 squared plus what? 5b plus c. But you know that equals what? 0 because it tells you it's 0 right there. Now what about g? What's g of 5 going to be? True, but you plug it in here. What's it going to be? 25a plus 5b plus c. But what do you know that equals? That equals 50. So here's the thing. You're trying to solve for a, correct? But how many variables do we currently have? We have 25 plus 5b plus c is equal to 0. But what else do we have? 25a plus 5b plus c is equal to what? 50. The challenge is you have 3 variables but only 2 equations, so you think to yourself, man, I'm stuck. Do you notice a similarity between the two? What do they both have? They both have 5b plus c. The easiest way I can say to recognize what you should do, see this one? What does 5b plus c equal? Close. Negative 25. Does everybody see that? If I subtract 25 from both sides, you end up with this. What can I now do with this? Yeah, no, plug in substitution. So what do you get? 25a, but what is this equal to right here? What does a equal?
3.
Yeah. This right here, everybody, is almost entirely a reading comprehension question. Did you plug the numbers in the right space? And then when you looked at it, oh look, 5b plus c is in both places. Another method they might have expected you to use, another method is this. How many people have done linear combinations before in their algebra class? Anybody? Maybe? You can add, this is important, here's the other method. You see this right here? This is important. You can subtract equations. What's 0 minus 50? What's c minus c? 0. What's 5b minus 5b? 0. What's 25? Oh, it's 25 minus 25a. Look what we have. So we have so we have 25 minus 25a is equal to negative 50. So what do you end up with? 25a is equal to negative 75. Oh, a equals. It's the same thing. This right here is called linear combinations. You don't even have to multiply anything. You just subtract. The key is recognizing 5b plus c is in both. You also have to make the baseline. You got to know what a median is, right? This is one of those things where like you got to know your mean, median. Yeah, you do have to know what mean, median, and mode are, right? So it's asking you for, in these lists, blah, 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 blah. They'll have a new median. What is a median? The middle number. If you have a list, how do you find the median? Yeah, first you have to make sure they're in order. And after you've made sure they're in order, you cross off the first and the last, the next ones, and then whatever's left is the median. If what? Oh, and what do you do? Yeah, what do you do if you have an even number? You average the two, exactly. But here's the thing. If you add a number to both of these lists, how many entries are there going to be? There's going to be 7 entries, right? So you don't have to worry about that. So what you can do on this one, what do you think the best method is for this one? There's only 5 possible answers. Test it out. The key thing is you're not plugging into the same number into each place. You're plugging in x into the first number and what into the second one? 2x. So let's try a here. What are we plugging in 2? So it becomes 2, 3, 4, 5, 6, 7. What's the median? Oh, there's 2 of them, sorry. What's the middle number? The middle number is 4, right? What number do I plug into the second one, though? So it's going to be 1, 2, 3, 4, 6, 6, 8. What's the median? Oh, look, we just tested it, and oh, it's A. I noticed that on a couple of these that are testing, best done by testing. Mr. Taleo was telling you something else, though. When you find one that is really nice, and you're really sure of it, yeah, be confident, but you should also maybe do what? Maybe look at the other ones and just see if they break. You don't want to misinterpret your nice answer, because are they going to lace these with really tempting wrong answers?
No. Yes.
No, yes?